Thank you guys for coming. I'm going to talk about multi-access edge compute. I'm going to do the introduction, and then the technical details will be done by Anurag. We need to put that up front, you can notice. So at a high-level perspective, 5G is bringing the cloud to the multi-access edge. Basically, in the past or the previous technologies, you have to go all the way to the core of the network. But with 5G and the big focus on latency, it is very important to make sure that you actually get access to the data where you need it and when you need it. You need to have that flexibility. Otherwise, just the fact of physics, if you actually have to send the data for a long distance, that could by itself lower the budget of latency. So the whole idea of getting low latency is to be able to access the data, and multi-access edge compute provide you with this flexibility to be able to access the data early on and not having the data go all the way to the core of the network. And also what Intel brings to you, the cloud technology itself bring it to you at the edge. So you'll have a consistent platform, you have a consistent architecture that you develop and you deploy from the cloud all the way to the edge and all the way to the device. There are lots of potential opportunities when you actually combine edge compute with cloud-like applications at the edge of the network. That goes from smart cities, connected cars, gaming, and just plenty of opportunities. And I have seen it when I talk to customers. When you actually explain to customers the ability that you actually can provide them with large number of compute on demand, that will actually create quite a bit of innovation in their minds. And they actually have different ways of looking at how to solve the problem compared to what they actually have as of today. As I said, it's very important for a developer to make sure that their investment is really worth it. And from that perspective, we want to make sure that no matter where you actually write your application, no matter how you develop your application, you develop it on the same set of tools and on the same architecture, so you can leverage it all the way from the cloud all the way to the edge of the network. And it is very important for us from a strategy perspective, as I said, to give the developers and the application developers the ability to move compute where they need it and when they need it. And we don't want to have any barriers or restriction from that perspective. So somebody will ask, okay, why should we do edge compute? It's going to depend use case by use case basis, and it has to make sense from that perspective. So there will be a total cost of ownership where you actually put the compute, and also there will be benefits. And so it depends on the use cases, depends on the application. You actually will look at where you want to place your compute. So if you want to actually have a very low latency, you either will put it on-prem or you put it very close to the huts or close to the base station. If you can tolerate more latency, you can put in the local CO where you actually have more space and you can actually put more compute in there. And so you can actually go with it from that perspective. And also it is important to understand that edge compute is not just only about latency. Edge compute will give you the flexibility to basically optimize in cases where you actually have a huge amount of data generated and what the people call the gravity of data. If there is no need to send all this data to the backhaul, there is a cost associated with sending all the data to the backhaul and to the cloud. There is a cost associated with that. And also, there are certain cases when you actually, the reliability of the network is not really there. So you actually will need to do edge compute to actually have consistency and reliability of the network. So there are many potential reasons for somebody to deploy edge compute and not just send the data all the way to the cloud. When people talk about the edge, we have to be open-minded. There are many different definitions of the edge. Most of our focus from networking group is on the telco edge or network edge. But as I said, from an Intel perspective, we are looking at basically deploying compute anywhere, at any time, whenever you need it. So from our perspective, we also look at the edge, be it on-prem or in the network telco or in the data center from that perspective. So the breadbox shows the communication service provider's view. It's part of their network, and it is when the data crosses the point of demarcation to the comm service provider's network. On the other hand, the enterprises, they review their edge as on-prem. And you can see today that companies like Microsoft and Amazon are creating their own light stacks that can sit at the edge, and in their mind, they're licensing that so you can actually put it on-prem, or you can actually put it in the network edge also. So as you can see, the industry is moving into giving you the flexibility to put compute where you need it. I touched about the key drivers for edge compute. And most of you here, if you are developing application for edge compute, you probably have seen this or know about this. So low latency definitely is one of the key drivers. But as I mentioned earlier, the reduction of massive amount of data generated by the IoT devices, which people now call it basically the gravity of data. So you go closer to where the data is generated, and so the data actually basically pull you in closer to where the data gets generated. Of course, there's also data privacy and data sovereignty. So there are certain countries, they have certain restrictions on where the data can go. So you need to localize the data. Also, if you actually in a medical hospital, what have you, there are also restrictions about where the data can go from that perspective. In many cases, they don't want it to really leave the premise from that perspective. Then the other reason for edge compute is context awareness. You can actually provide a better user experience by understanding, where the user is, their location, and also what kind of quality of link he has. And if that really changes dynamically, you can change what you actually deliver to that user. And that's many of the areas where people are doing quite a bit of work to provide a better quality of user experience based on the context of where the user is and the quality of the link and the network KPIs. Also, as I said, scenarios where connectivity is unreliable or limited. So if you're in a cruise ships, you have a satellite link, from that perspective, you try as much as possible to minimize the amount of data that has to go. You only send the data that needs to go there to provide a better quality of experience for the user from that perspective. So from a networking group within Intel, within the data center group, these are the building blocks that we provide to our customers. On the access side, we provide a virtualized multi-RAT software as a reference. We also have that supports both LTE and 5G. We also have basically virtualized for cable, for fixed line. On the edge and the core of the network, we provide a reference for a virtual APC. We also provide our MEC SDK, where Anurag is going to spend some time to explain and provide more detail. Then we also provide and help our customers with the architecture. What kind of CPUs they need, what kind of power profile they need to have in there, what kind of accelerators they need, what will be more optimal for their use case scenarios. And then on the capability enablers, we have visual cloud, so we have computer vision SDKs. We also have some accelerators that helps with integrated GPU inside our CPUs and does transcoding. At the same time, also we have an AI capabilities and big libraries. And of course, all this will end up being with our basically NFV SDN with the cloud-ready networks, where we actually also provide many, and we contribute many to the open source community about the building blocks from that perspective on NAV and SDN. With that, actually, I'm going to have Anurag. I don't want to really bore you with stuff anymore. We'll have Anurag actually dig deep and provide you with more details about our NAV SDK that we provide to the community. Anurag, I'm going to drive the slides. You tell me which slide you want to be on, and I'll take it from there. I'll move the slides for you.
Thank you, Naser. Okay, so the first slide, let's stick around on the system architecture slide. I want to spend a couple of minutes. So in this particular section, we'll be covering high-level architectural overview, and we will try to get a view that, first of all, let's understand what is MEC. And I'm sure just people have their views, and then most of us are already in agreement. So MEC, and just to make sure that we all are on the same platform. So MEC is a third-party trusted application deployment framework at the edge of the network. So this is for third-party applications and at the edge of the network. And we'll see in this particular section for the technical architects and the product managers and the business leads, what are the contours of the opportunity? So what is in it for all of us? And its relevance for 5G. And then as you'll see, we will briefly touch, in the phase 2 of the 5G, they promise service-based architecture, which opens doors for third-party application developers beyond the traditional telco supply chain. Think what apps did to smartphones. So we could potentially have lots of opportunity coming up for application developers, for different kinds of players in this area. Now let's look at the HC view of what is a MEC system, what are the internals of a MEC system. So this is a block diagram representation, and I'll point you to two key building blocks there. So the first one is the mobile edge host. So that is the host for running third-party MEC apps. And you can see that there is a virtualization infrastructure, and then there is a debate going on, one type of virtualization versus other type of virtualization. So the text is agnostic of that. All that it says is that there is an environment in which third-party applications, MEC apps, can run. There is a control layer there, is part of the MEC mobile edge platform, so there is some control processing going on there. And also, the second important block is outside the mobile edge platform element management. Okay, so these are the two blocks which we'll keep coming back to. Apart from that, there are other elements there which are important especially from NFC point of view, from orchestration point of view, etc. But we'll keep returning to these two. Okay, next slide. Let's go to the next slide. So the next slide. So I think Naser, let me request control so that maybe I can try myself. Yeah. Yeah. Okay. So let's look at for different players and different people, what does it mean? So people with application developers concept, so user experience. So you are an expert in understanding what user experience means, and and you can develop applications around them. So for them, applications and services as MEC applications, there are lots of opportunities there. Next, those who have orchestration, operations management skill set, there are opportunities in this area. Platform companies which have skill set in virtualization, hypervisor, container virtualization, etc. So there's lots of opportunity at platform level. And also for the system integration, overall how the different building blocks they work together. So there's opportunity for them. And further, there is opportunity for adjacent DNS providers. And then that comes in because the whole software is getting virtualized. So there is ample opportunities for them to explore adjacent opportunities. Okay. The next slide shows a 3D view of MEC, and this is the 4G view. So the previous slide we saw was the internals of NAC, and that is defined by HC. 3GPP view is it shows how it works with different blocks in a mobile network. So we see there are two options. One is when it resides on the S1 interface, and the other one is when it resides on the SGI interface. It is important to also note the second one because it provides an opportunity for IP traffic and for the Wi-Fi connectivity also to be via the MEC platform. So that's opening more opportunities for different kinds of configurations and deployment scenarios. Next slide, and this is MEC in 5G. And I would like to use a word of caution there. So this is specs in development. This is currently there's only phase 2 of the specs is out, and phase 3 is still under discussion. So this is based on many of the interfaces here are not clear, and that's why I've marked them as FFS. But this is what we think where the discussions is going, where we would still have the traditional division which we are seeing in 5G, which is databases at the top, control layers in the middle, and then user plane layers at the bottom. And then interfaces between the control layers and the user plane layers. It is expected that there will be an application function which will do the control plane signaling, orchestration, management, also have data related to specific applications. And then there will be MEC host which will be shared between the RAN, part of UPF, or the data network. There could also, what I've not shown is the local data network versus central data network. There are multiple networks possible there. Okay, so this is, and the reason why I would like to also mention why this is important is that in the phase 2 of the 5G, I think I did mention earlier, it promises service-based architecture, and especially for the control plane entities where they can query from the port, respective port, and discover the services. And some of the interfaces like N2, N1, N4, they have been discussed, but the interfaces, the MEC-specific interfaces which we expect will be relevant for us, they are still under discussion. Okay. So the next slide. This is specifically for the application developer, and my understanding is that most, if not all of us here, we have interest in application development, and this shows a 3D view of what does an application do. So these are the applications which can be consumer, they can provide a service. What 3GPP does is or FC does is provides these platform APIs and the applications and a model. Sorry. And a model in which the applications, they use REST HTTP style APIs to register services for lifecycle management and for different control purposes as well as and they interact with these APIs with the underlying host. Okay, and lastly, what I would like to mention is this is a system integrator view, how multiple MEC, RAN, and core networks would interact with UE mobility, etc. And so the picture becomes slightly more complicated, and this is how people with skill set in this area they could leverage this architecture and then provide additional new kinds of services with UE mobility, with application discovery, with reconnection of UE, new path discovery, etc. Okay, so this is moving on to the next slide. So I'm struggling with the slide navigation. Okay, what is available from Intel? Before we move on to the next section, is there anything you would like to, are there any questions on the previous section?
The question is on the 5G slide. How is the mobility handled on that diagram?
Okay, the key thing is that it is not yet fully defined. This is the stage 2 is what has come out, And stage 3 is still being defined, and I think over next year or so, I think later this year, I think a lot of things will start coming out, draft specification, and later within a year or so, we'll have more clarity on that.
Right. Do you have any perspective on that?
So so here is what this is the perspective that we think, and this is something that we have had a lot of discussion internally. There are two papers that are going to come out. One is Informatics. One is MEC, how the migration will happen from 4G to 5G, and the other one is how is MEC going to work in 5G. Okay, so a lot of discussion going on internally as well as within the SANS body. And so there is this this is mobility element here. And that information, that mobility information is stored there. And we expect that based on these service points, we will have information flow between those. And also, this interface has not been defined, so there will be information coming through this interface, and also from the control plane, also some information will pass through. Specific details are not published yet. But we expect that these elements, apart from the NEF also, they will be used for discovery and for reconnection and for mobility. So the history of it is that we had a release 1, which was atom based. We no longer do that. We have now release 2 and release 3. These are Xeon based. With release 3, we also came up with a software only option. The release 2 or the Xeon based is a Wind River bundle, which is optimized for Xeon server and our NICs, etc. And the CentOS one is more flexible, which is tested for Xeon. But what it does is it provides you an environment to develop applications without the dependency of having the right hardware, the Xeon hardware. So that's the advantage. And what is there inside the release? This is the latest release. What's there inside it? So this slide captures the release 3.0 features. So there is a software-only version available. It provides support for both S1 and SGI interface, and support for GTP-based on IPv4, etc. VLAN tagging is supported, but editing is not. And then there are reference MM5 APIs supported. We'll have a quick look at which APIs are supported later. There is a logical port abstraction for DPDK, and you could use DPDK or you could work with the OS provided libraries inside the VM, but it is better to use the DPDK because of its efficiency. And we'll briefly also talk about the 4 types of NEC app services supported. So we'll have a more detailed picture of what is internal NEC SDK architecture. Okay. So the HCMAC specification we saw, this picture captures what is it provided or what is it that we provide in our NEC SDK. We provide on the host side, we provide sufficient environment for you to develop apps. We provide a virtualization environment. This is the ones that are currently published. They are virtual machine based, and there are other alternatives also being worked on. There are APIs for managing those apps, for lifecycle management, and there are some emulation for the virtualization infrastructure management also. So we talked about Wind bundle, and we also have a CentOS 7 based bundle. So in the Wind River bundle, there are 2 platform solutions. I think the next slide should capture that, which is one for the compute, the other one for the control. NEC SDK is running as a platform. Your VMs applications are running in these VMs. So the controller, this is the ME manager emulator, and then they connect to the eNodeB and the EPC emulators. In our case, we use Polaris. You could use the favorite emulators also. The software-only bundle, it provides a way of, this shows it provides a way of integrating on the SGI side, but you could also use with the eNodeB and EPC. But in this case, it shows that you have got one hardware and ME emulator is script-based on the same platform. Okay, what is the difference between the two in terms of the software stack? This shows a high-level view, and I'll quickly summarize. The main difference you will see is the AVS and the DPDK that comes integrated with that for the accelerated virtual switch. This is from Windows. It has been optimized on our hardware, and it has been characterized, etc., for providing near real-time latencies and the throughput, etc. So we do not provide integrated, at the moment we don't provide CentOS 7 bundle integrated with the OpenVSwitch, but if customers who are developing based on this platform, they are free to use and integrate it and get better performance in the native CentOS 7 platform. But based on all the work that together with Windows team and our software engineering team, they have put in for out of the box real-time application, latency, etc. Those are the concerns that this is the right thing. If you are developing applications, if you just want to know that you are using the APIs correctly and you are able to prove that your application itself is working correctly, then you could also go for the CentOS 7. In fact, the newer version of the NEB SDK, the architecture is slightly different, but I wouldn't go into that details now because we don't have sufficient time. This is an important picture, so I wanted to spend a few minutes on this one. This shows how the VM applications they interact with the platform, and how the platform interacts with the underlying OS and the hardware, and that further how it connects with the network traffic. So you have traditional eNodeB to EPC S1 traffic going through. It is what they call bump in the wire configuration, where the packets come in, are processed. The platform decides that these are the packets which is of interest to it, and it further provides to the VMs, or it goes to the egress port especially for the controller user plane separation, where there could be distributed virtualized as gateway and P gateway, and the tab, and you're getting IP traffic. Again, we could look at the IP layers and then do similar filtering. And then something similar also for the Wi-Fi gateway. Now there is option to do a breakout if the rules require. If the configuration is, and this is where specialized handling becomes important for media processing, for content. We talked about streaming earlier. Similar, graphics processing or transcoding or different kinds of application, or for local breakout also, access to the internet. So there is a pathway for that, and we will see the use of this in our architecture next. Okay, so this consists of two platforms: the host and the controller. We talked about the NEB SDK, the NE platform itself. We talked about NE applications. We talked about the various interfaces and how the traffic flows through for GTPU and non-GTPU traffic. Okay. So this is go too far. Come to that. This is an important picture. We'll come to that. So talk about this. So by default, we support, and let me spend 1 minute on this slide. By default, we support 4 types of applications. So there is a consumer application and there is a producer application. The producer application provides data and consumer consumes it. The application could reside in a virtual machine, or it could reside on the platform. It could be stored locally, or it could be provided directly. So it's based on where the processing happens, whether in a VM or on the host, where the data is stored, whether inside the VM or on the host, and how it is provided, either directly or through the platform. So authentication is important if it goes via the platform. The next slide shows, so this is the direction we are moving in, and this is where we think that how our edge cloud reference architecture is going to look like. So we'll have on the SIS, and this is many people are interested in such kind of architecture, which addresses earlier questions about whether the MAC is closer to the, it's anchored close to the core or close to the RAM side. So what we see is that this will be virtualized RAM capability, maybe distributed SMP gateway capability integrated on the same platform as a NEC, which could also have, and this is a lot of interest coming in from the likes of applications for IoT applications and Amazon and Azure and Ali kind of cloud service provider, and how the integration will happen. And in this particular case, we expect that this is one possible solution, that we will have wrappers, and then using the breakout, and we will offload those traffics to the respective services, and then further from that they could take it up. Okay. Let's jump to the. Okay, so a quick view of the APIs. So the two different kinds of APIs, MS5 and MP1 APIs we support, and these are all RESTful APIs. There is a API programmer's guide that we provide. And these list of APIs, MM5 APIs, is essentially around application lifecycle management, and then live indicator, terminal service management, subscription management, traffic rules management, etc. Okay, this is kind of, this is there. So these APIs are not 100% tech compliant, because some of them we started developing while the MEC specification were being developed, but it is always a endeavor. We keep making sure that we comply as closely as possible to the SC MEC specification. So working with us, how does it work? So the way, and this is the process that we are following until now. Things may change later, but at the moment the way we work is that anyone who requests any SDK, they go and request for the license from this portal, and then when the portal team provides us the request for the validation and for the to understand what is your requirement, we ask you questions about your project scope, what's your success criteria, your timeline, what kind of hardware you will be using, so that we know that we have tested for that, and in terms of it does not cause problems in using the software, where will it be located, so that we can connect you with the right teams, and any context. How does your use of our libraries, it helps us with creating collateral, and that can be used for the community. So these are very important factors. And then we provide, when we accept the license, then we license, we provide your license, and you accept, and we provide you the link to download from Intel portal. Okay. So this is now let me summarize this quickly. In conclusion, so this is what we have seen in terms of where our NESDK is currently being used, from network operators to standard bodies, equipment manufacturers. Some are creating business value, some are creating opportunity, more of business value, more of opportunity, and there are independent software vendors who are creating both. So community like you create new applications, new business models, and we see there's a lot of interest going on there. A lot of people in different areas they are working on. With that, I will finish my session.
Thank you, Anurag.
What is the perspective on power requirements at the edge? Because some are pushing ARM-based services at the edge, and Intel processors are known to be more power consuming. So what is your perspective on?
So what I would, so there is a lot of different considerations going on, but what we see is what MEC provides you, that virtualization infrastructure, that capability, that flexibility that it provides, and where will you keep that MEC, whether it will be on the deep in the data center or next to the edge, whether it is co-located with other VNFs, etc. So when you factor all of that in, and despite all the hype about power, and I think some of that needs to be punctured in terms of there are Xeon platforms which give very good performance per watt, and I wouldn't be able to cover that in this. But what I would say is that there are a range of deployment configurations and the kind of flexibility that people are looking for that you would get from Intel architecture from Xeon platform. And I haven't seen many interest, and maybe there is something that I need to look at about ARM-based systems. I mean, maybe we can think of later if you want on interesting applications that are happening.
Yes,
So-
I mean, it depends where you deploy and what would be the requirements from that perspective. But if you really need the virtualization, you need basically the scalability to be able to move compute from data center all the way to the edge. It will provide the best value. And also, we just announced like the Xeon D family, which is an integrated SoC. And of course, you can go. So it depends on what you need. Then we have also the Atom-based, also platform that also provide low power. So we definitely have all the way from the Atom-based, which is low compute, low power. Then you can basically scale all the way to the Xeon SP, which give you the best performance from that perspective. So power is going to be a consideration. And
So the release 3 also supports Atom.
Sorry.
The release 3.
No, release 3 does not support
it
that.
does not. But I think there is enough there for the community to actually take what we have and actually put it to